is Muhammad Fahad University, came from Saudi Arabia, and it's my privilege to introduce our first speaker, Dr. Ala Salman. He will go to talk about estimating time, cost savings for residential building in Saudi Arabia. Now your floor, Dr. Salman.
Thanks so much. Good afternoon, everyone, and I'm happy to be here with you. So just would like to give you a short story about the work for this paper. Okay, before I start, let me tell you something. So last year, actually, I published a paper. So this is what I published last year. So regarding learning curve, to develop the learning curve. So learning curve is well known in this realm, okay, because we have continuous operation and quality, so everything is clear. But in construction, it is very difficult. It's not easy. So however, one of my colleagues is named Dr. Bandar Al-Qahtani. He's an Imam Abdurrahman bin Faisal University. So he told me, so he's also an owner of construction company, I say that. So he told me, I'm gonna to build a new project, to work on a new project with 4 buildings. And I would like to use the methods that you used in your paper, okay? So because of that, so I use the methods and I use these 4 buildings as case study. So what you will see here, the method, I'm going to explain the method in the paper that I published last year, and also I'm going to show you how I applied these methods in the 4 buildings.
It should okay now.
Okay, so this is my agenda. I will go with the problem statement. So here I'm talking about owner perspective, okay? So usually at the early stage of the project, okay, so we need something more accurate estimation, okay? So what we found actually, we found some activities, construction activities, they are repetitive. What does mean repetitive? That means, so the same crew, they are going to do the same work again and again and again till this activity to be done, okay? Such as what? Such as column rebars, okay? Beam rebars, and also slab rebars. So accordingly, so we said, so let us apply the learning curve methods in this 4 buildings. So this is what I said. This is the paper that I published last year, and let me explain the method easily. So assume that you have 20 units. This is just example, okay? Assume you have 20 units, and these units, so they need time to be finished, okay? So of course, when you talk about your work about the first one, okay, so it will take more time. So assume here it is using some data collection from previous projects, almost similar project. So the first unit, so it needs more time, okay? So as example, it needs 5 hours, okay? So from where we get this? Usually, if you go to your city, okay, collect the project similar to this project, okay? So try to find the worst case, okay? We call the pessimistic project the worst case for the first one. Assume it is, you need 5 hours to be completed. And also you have to go with the optimistic case, okay? So assume, so after good training, so after 20 like unit, so you can complete the same work within 1 hour, okay? This is again just example, just to show you the method. So what will happen here? If you would like to draw a curve, okay, or to identify the curve, so what we need? We need 30 points. You can tell me it's easy just to connect it, a straight line will be easier, yes, but it's not accurate, okay? Curve, it could be up, it could be down, optimistic, pessimistic, okay, depends. But if you go to your projects, current projects, that means your current project, you can consider your project, it is a point. It could be in the middle, it could be beyond, so it depends, okay? So how we can get, where is the location of your current project? So x2, y2. If you assume this is x1, y1, this is x3, y3, so where is x2, y2? So we said, okay, so let's investigate the situation, why this is pessimistic, why this is optimistic, and also the current projects. Using what? Using some factors. So we collected the most 21 factors that affect the productivity of the construction activities. So in this case, and also we selected 5 top factors among these 21 factors, and based on 1 to 4 scale, we can identify the total score for pessimistic, the total score for pessimistic, optimistic, and also for the current project. So these are the 5 factors: experience, ways, availability of tools, site condition, weather condition, and you can give them a scale 1 to 4. Of course, 4, that means it is ideal, great. 1, it is very poor. Okay? So using the equation of multiplying these number from 1 to 4 for each factor, multiplying by each other, because these are independent factors, so you can get the total score. So you will get the total score for pessimistic, optimistic, and for current project. So what you will get? You will get the total score. Now, if you get the total score, if you multiply 4 to power 5 will be a huge number. Okay, but we need something to fit within the 20. Okay, so I'm talking about the units. So x2, to identify x2. So if you are going to use the exponential equation here, so you can get the value of x2 which within 1 to 20. While to get the duration, get all the projects that you have collected and identify the duration, you can get what? And using specific software, so using artificial neural network, you can get exactly where is y2. So in this case, you can identify x2 and y2, so you can identify where is the location of your current project. So assume you get your current project here. That means at unit 8, so it needs 3.8 hours to be completed. So you have 3 points, and simply just connected, you will get the learning curve. So if you get the learning curve, you can get the equation, the mathematical model. If you get the mathematical model, you can estimate exactly the required time, and accordingly, you can get what the required cost for each unit. Instead of just getting only time for one unit, so you will get exactly how much the exact time for each unit. So this is, in general, the method that I published last year. So for the 4 buildings, so what we have, we selected the rebars for column. So we have 3 types of columns. We have 2 type of beams, and we have 1 slab. They are typical. These are 4 buildings. But these are 4 buildings are located in different locations in the same city. It's called in Dammam city in Saudi Arabia. So these are the number of, for column 1, 40, 50, 30. We have 55 beam this type. We have 145 beam this type. And we have 5 floor, that means 5 slabs. So these are the dimension, and these are the required crews. Okay, for each one of them, they are individual crew. They are going to work on the same activity. So we have 4 buildings, and I have 6 structural members. That's when I have to develop 24 learning curves. Okay, the cost here, I'm talking about the crews. Okay, the cost here for the column 1 till beam 2, so it's around 80 riyal per hour, so around $20. And here 164, that's that. So using, I'm going to just to show you example for column 1 of the first building. So if you assume this is optimistic for the 5 factors, 4 to power 5, you will get 1024. Use the equation of exponential, you will get 4. This is the maximum. For pessimistic, okay, 1, 1, 1, 1, this is the worst scenario, you will get 1. So where is the current project? Where is the location? So the location of the current project, based on the factor, see, is 1 to 4. You will get how much the total multiplication? 432. If you use the equation, you will get 3.37. That means it is between 1 to 4. We identify what? The x2. Okay? What about, so using the interpolation, you will get x2. So that means I have 1 to 40 columns. For 1 to 40 columns, so my current project will be located in what? In column number 32. So we'll identify the time for this 32. Using what? Artificial neural network. So I use this software called NeuroTools 7.5. So using 10 projects, and this is my current project, you will see I use the minutes as duration. So you will get around 156 minutes, and here predicted. This is using the artificial neural network. So that means I have X2 and I have Y2. This is only for what? For the first column of the first building. So accordingly, I'm going to do the same thing with the rest of 23 models. So here you will get. So this is for column 1, column 2, column 3, beam 1, beam 2, and slab 1. And for each one, you will get project 1, 2, 3, and 4. And this is what you get. I get the first column of the first building, the X2 here, 32, and the duration 156. And I develop the curve accordingly. So if you develop these curves, so directly you will get what? The mathematical models. If you get the mathematical models, so for each one of them, what you will get the required time.
2 years.
Okay, and here it is. Accordingly, you will get the saving. So for based on the saving of how much is the saving, this is for column 1, 2, 3, beam 1, beam 2, beam 3, and slab. So, and as a result, so the saving you can get for time between 16 to 20%, and for cost 19 to 24%. And it looks like project 2 is the best project. Why? Because the condition it is best, and accordingly these current results so will help the owner to understand how much it is the saving in cost and time. So limitation. So I work in in limited area, limited region, limited data. So that's why we need more data. We need more statistical tool. And also for future work, maybe you can consider other activities, not just the rebars. As a conclusion, so this is a 3-point technique to develop the learning curve in construction. It is very practical and very simple, you can see here, and can be used to estimate the required saving in the cost and time for construction activities. And with respect to develop a learning curve, so we can identify the cost and time for all other activities. Thanks so much. Any question?
Do you have a question to Dr. Ala?
Yes.
So you have your learning course from